sunshine I gotta love, and I know that it's all mine. Whoa.
Hi everyone, so it's been about a year since I've added to this channel. Now that I'm back in school, I've come across some things that I want to share with you. The things on today's agenda are mostly tips for design students who need help. So this evening I'm going to be going over just some tips for making topography. So building pads and like splitting topography. I'm going to explain what Project North is and how it can be an asset to you when you're working in your project. I'm going to go over more details on how to use your Rhino model that you made for massing or schematic design. And then I'm going to explain to you just a quick roof tip that I recently discovered that I would like to share. So I've made a previous video explaining just how to create topography, like existing conditions from a CAD file. And then I also showed you in that same video how to model just kind of like massing for your context. So I won't go over that. You can watch the other video. When you're manipulating the topography on your site and you actually want to change it and you don't have a CAD drawing to work from, you're going to have to create your own topography. So to do that, you just use this Topo surface tool under massing and site, and you are just going to start clicking. You're just going to click where generally you want your topo surface, but it doesn't have to be perfect. You'll notice when you are clicking, it just goes to the outermost point. So even if you want your form to curve like that, it won't do that. It'll just connect those outermost points. Also, when you're clicking, you can add however many points you want, and the elevation that you're clicking is specified up here. So we can come back and change all of those heights, and we can even delete points to make it more simple at any point. So that's how you just create a basic topo surface. I can just show you if I were to click on a whole bunch of these. I can now adjust the elevation like that. Now, if I want to crop it, it's not that obvious, but you're going to use the split tool. So in the same massing and site category, I'm going to say split surface, and then I have to click on the surface that I'm going to be splitting. So I click on it. Now this brings me up to this familiar dialog. So I can either go like this and just use one line and make it go past the boundaries there. And this will be like where a scissor would go. So I can go like that, and then it'll split that surface in two, and then I can delete this, or I can say split surface, click on here, and then draw a shape like this. And it will divide that surface into two. Like that. Now, if you made a mistake, you can always undo that by clicking merge surfaces, and I'll click here, and they will become one, and it'll be seamless. You'll get rid of that line. So the other tool that you're going to want to use while adjusting topography is the building pad. So this will just go wherever your building is, and it'll act as a flat plane, and you tell it what elevation you want it to go at, and it'll void out everything above that that plane that you set. So for example, in this scenario, this is my topo surface, and then I have a building pad cutting out here. So one thing that I noticed recently that I just wanted to share is that if I put a building pad in like this and I give it an elevation, so I wanted to cut like a pathway through this earth. And when I put it in here at the height that I wanted, it actually raised the earth on the other side as well. So that was really convenient and really helpful for creating like a path. So I just wanted to share that. Lastly, for creating topography, you don't have to use the Topo tool. So if you want to create something more regular like this shape here, this would have been a pain to create using the Topo tool, because I would just be pulling and pushing points down and up. So to get like a crisp edge like this, it just would not work. So I created this piece here by just doing a model in place component. So just go like this, click model in place, and you can specify what it is. You could say topography, or you could say like generic model. So I'll say topography. So the model in place component tool is really useful when you're doing massing or schematic design. You can use these tools to model as if you're in any other 3D modeling program, not a BIM software. So I can just create extrusions and sweeps and solid geometry in any form that I want, kind of without limitations or categories. So now I have this piece, and I can even assign materials to them. So I can go like this. And then if my material is not there, you can say create new material. So for this piece, for example, I wanted it to match the topography, so I called it earth. So in this case, this piece is just an extrusion and a sweep, and then I just voided the edges. So that concludes my tips for topography. So now I'm just going to explain Project North. So it's pretty common that when you set up a project, you make the project and the context facing true north. So in this project, this is the Canadian Parliament, this is the Ottawa River, and this is our site. And in this case, my building is on an angle. So when I'm drawing things like walls and my structure, it's going to place perfectly up and down, which according to my building will be on an angle. So I would much rather use Project North. So I'll just show you the difference. This is True North. And then in my properties panel, the orientation here, I can just say Project North, and the whole thing will rotate without me having to manually rotate, because we wouldn't want that. So I'm just going to use this blank file to show you how to set up your Project North. So in a blank file, your Project North and your True North are the same because we have not set them. So here you can see they are the same. So using this drop-down menu under Manage, we're going to go to Rotate Project North, and you can use these, or you can say Align Selected Line or Plane. So I'm just going to select this. So the project can remain geolocated, but now I can work in right angles, and it's just a lot easier. So now I'm going to give you some tips on how to utilize your Rhino model in Revit. So I know it's really common for people to use Rhino when planning out their massing strategy. It can be a lot more free to create weird forms. So for example, this form here was really easy to create in Rhino, but to get this beautiful curve here, it would not be that easy to create in Revit. So what we can do is export just the form that we want from Rhino, export it as a CAD file, and import it back into Revit as a CAD file. So I'm going to select what I want. I'm going to say export selected. And now I can export it as a DWG. However, with some irregular geometry, Revit will get confused and it'll just not show up. So I find that SAT files are more useful. So this is what it is. It's ACIS SAT. So I'm going to say save, and I'm just going to leave the settings as default. So now we have two options for importing our Rhino model into Revit. So we go Insert, Import CAD, and then it might be set to DWG, so you can just change that here to SAT. And now I'm going to click this, open, and now it'll show up here. So the SAT file imports just a little bit different from DWG. If it's a DWG, it might automatically be turned off. And also if you type VV or go to visibility graphics, it'll be under imported categories. So you might have to turn this on if you don't see it. For some reason, the SAT files are not under here. I really don't know why. So when we just import the CAD, we're basically just using it as a guide. So now that this geometry is here, we can just go ahead and use the Revit tools to build something that resembles this. So the second option is if we actually use this form to create Revit geometry. So we can do that by creating a mass. So I'm going to click on Massing in Site and then say In Place Mass. So now we are within the mass tool, and so we can go to Insert, and we still have that option to say Import CAD. So we're going to do the exact same thing, but this time the CAD that we imported is like within our mass model. So I can go like this. So as you can see, this one is just a stat file, but this is a mass, which is Revit geometry. And once you're done your mass, you just click the green check mark. So now that we have our Rhino geometry registered as a mass, we can use these three commands, floor by face, wall by face, or roof by face, to stick a wall, floor, or roof onto these faces. So I will click roof, and then I can click like a whole bunch. And then I can say create roof. And now that is just a one solid roof. So if I click on our original mass, we can delete it and that roof will stay and it is all one piece. And we could do the exact same thing with the wall or the floors. So for example, the walls, we can just click a whole bunch of those faces. And now we have walls that perfectly line up with our Rhino base model. And then we can delete this or hide it in any of our views. So the benefit of doing this in Revit instead of Rhino is obviously you can just create drawings right away simultaneously, and everything is scheduled properly. This roof is registered as a roof. I can add different layers within my roof. I can add structure. These walls I can also add layers to. And because windows stick to walls, I can now place a window directly on that wall. One downside is that windows in Revit need to be placed on walls. So if I click on a window, I can stick it on a wall really easily, but I cannot stick it on a roof. So basically you'll have to create your own family or download them by go to File, New Family. And instead of creating a window that is wall-based, you'll just create a window that's face-based. And that way you can stick it onto anything, a wall, a roof, a floor. You're not limited. That's it for my Rhino to Revit tutorial. One last thing that I wanted to show you in regards to creating crazy roofs is that you can create them as a model in place component. And this time I'm going to specify that it is a roof. I do this just because the roof tool is sometimes really limiting. So for example, if I wanted to create a roof that's just like a really weird shape, or like was created by a sweep and then cut voids out of, something that the roof tool doesn't let you do. So because this model in place component now is registered as a roof, we can actually tell the wall to connect to it, which is just really nice for when you're detailing the building or trying to make it airtight. It's nice when things connect properly. So that's it for this tutorial. Let me know if there's anything else that you want me to show.
For the sunshine, I gotta love, and I know that